mostly discuss the project assignment. This project is concerning Fourier series and Fourier transforms, and specifically we're interested in what MATLAB does when it takes a Fourier transform, as well as what it does when it performs these kinds of calculations on discrete data. So typically when we learn a Fourier transform and Fourier series, we're talking about continuous functions. When we actually do this on a data set, we're performing it on a discrete function. So there's some difference in how this is implemented, and it's sometimes interesting to explore different things in MATLAB to see what it does and where this creates an issue. So I'm going to assign some specific waveforms and a period at random to different groups, and there will be a document posted on how you know which waveform you're supposed to use. Once you have that waveform, what you want to do is find the Fourier coefficients for your wave. Usually you can find these tabulated, and that's fine if you want to use a tabulated version. And then you want to express this function in terms of the trigonometric Fourier series. And then based on some of the definitions that we went over in the previous lectures from the last week, you want to find the square error for a series having different number of coefficients. So 1, 2, and all the way up to 10. And then create a table that shows the error for each case. So you're basically looking at what is the square error for a single term, 2 terms, 3 terms, and so on. And so we're trying to get an idea of how many terms you have to have for the Fourier series to accurately represent your wave when it comes to the square error. Then, using MATLAB, I want you to construct a data set that represents 10 periods of your function. So if your function is a square wave, then I want 10 periods of your square wave. And when you set this data up in MATLAB, basically you can choose, as you set this up, you choose how many data points per period to have. So I want you to have 40 points per period. So when you set this up in an array, if you had a rectangular wave and you had 10 periods and you had 40 points per period, then you would have roughly 400 points, give or take a starting and ending point, to make things uniform. And then plot that data set to be sure that it actually represents what your wave looks like. Now, also using MATLAB and using the same digitization rate, also 40 points per period, I want you to construct a data set for each term in the series up to n equals 10. You can then plot the original data set and plot each term in the series and plot the sum of all 10 terms and see how well 10 terms in a Fourier series does at representing your original data set. Then I want you to, and obviously on a lot of those you can overlay a lot of those plots. So I think this says step 4 to 6. It should probably say steps 5 through 7. I think I added a step. So I want you to do that and display the graphs, and then be sure and write some comments in your report. From that point, I want you to write a MATLAB code that finds the error based on your data. So we're actually doing it like what you did for the continuous data set analytically in steps 1 and 2, we're doing for what you actually found in MATLAB with your discrete data sets. And then given these discrete data sets and calculating an error in exactly the same way you did in steps 1 and 2, so you would have an error for n equals 1, an error for a 2-term series, a 3-term series, and 4, and so on. And then compare the results that you get in MATLAB for that error with the results that you get when you do this exactly, and they should be similar. Now we want to go back to the step where we are constructing a data set, and instead of picking 40 data points per period, I want you to pick 10 data points per period. And I want you to rerun basically everything that you did previously and see how that changes when you choose fewer points for your function. And what I'm really interested in is I'm interested in some quantitative results as well as your qualitative observations. So what is this really telling you about MATLAB and things like sampling rate. And if you wanted to set things up in MATLAB to do these kinds of calculations, is the number of samples per period significant? And what fundamental thing in electrical engineering are we really getting at here, kind of related to the Nyquist criteria? So then in step 12, MATLAB has an FFT algorithm. Once you have the signal created from step 3, then you can easily take an FFT. And then, so I would like for you to take an FFT of the data that you created to represent exactly 10 periods of your data set. And then I'd like for you to repeat that step using your Fourier series with 10 coefficients and see if the FFT in step 12 and step 13 looks different by comparison. And you might think about what you might expect it to look like versus what it actually looks like. Now then, instead of having 10 periods in your function, I'd like for you to change to 2 periods and repeat steps 12 and 13. And I want you to be sure and keep the sampling rate the same. And what we're interested in knowing is what happens then to your FFT output and why. So what is the FFT? How does it look different? Does it look different? How does it look different? Why does it look different? And how would that long-term impact a data analysis project? Now on this project, I just want to be sure that everyone understands that when you have a project assignment, you don't handwrite that. This should be typed. Your MATLAB code should be submitted with your project, not as a separate file. So if you create an M file or if you run an analysis on screen, you'll need to somehow screen capture that and embed that into your Word document. You can copy and paste your M file into your Word document. Most of that should be done in the appendix. Your figures should all be copied and pasted into your Word document. You should have formal introduction and description of the project. It is not okay to list steps 1 through 10 and write your responses as answers embedded into the project assignment. So in other words, don't say step 1, find the Fourier coefficients for your wave, and then at the end of this, insert your answer. That's not an acceptable report format. So instead, you would do something like state the first step in this project is to take a waveform and find the Fourier coefficients. This was done by, we found the coefficients where, or we calculated the coefficients using, and then list your result. So it should definitely be more formal than the kind of work that I got for projects 1. And that should be throughout the entire. So these 13 guidelines here are not questions where I want specific answers for each question underneath the question. They are the 13 things that I will look for in your project to be sure that you completed the project. You should have obviously an introduction and a conclusion. Obviously, if you're writing a paper about the Fourier transform and Fourier series, you just should have a definition of that somewhere. And all of those things that typically go into a report. I want you to work in groups of no more than 3. You're welcome to work alone. If you would, please check the Blackboard site this week for an additional document that will assign what waveform different groups will have, and I'll just kind of randomize that based on last names because I don't know what your groups are, so I don't know who you're going to be working with. So I'll just list some criteria, and hopefully that means we get some different projects from different groups to keep it interesting. You will submit this through Blackboard. I will not accept any email submissions. So if you email me a project submission, I will not open it and I'll delete it. So the only way to do this is to submit through Blackboard. If there appears to be any problem with submission through Blackboard, please notify me sooner than the due date. So if you have a problem submitting, I have opened up Blackboard to allow for 2 submissions. So if you submit the wrong report or submit it early or can't get it submitted, then you have a second opportunity to submit that. But please, if you have any issues with that, let me know. And if you have any questions, please feel free to email me or post those on a discussion board thread. Otherwise, I think this should be a project that goes pretty quickly. I will just reemphasize that you must use MATLAB on this project because part of what the project is doing, I'm assuming you all know about Fourier series and Fourier transforms. So this is not to prove that you can do a Fourier series and a Fourier transform. The purpose of this project is for you to explore what the computational tool does when it takes a transform, and how is that better or inferior to what you do when you take a transform. So we're actually evaluating MATLAB's capability to do Fourier analysis. So that's a big part of what this is, as well as practicing a little bit with concepts like square error.